The project we worked on was a small standalone game called Keyboard Hero. The project was initially conceived as a simplification of a piano sight reading trainer we found in our research leading up to the project. This initial idea was transformed into its current form of a rhythm game similar in functionality to Guitar Hero. The aim of the game is to allow the user to play along to a song using a simplified keyboard interface and then score them based on their performance. Each note in the song is represented on the screen by a column, with blocks travelling down these columns toward the line. When the block hits the line, the user should press the key corresponding to that column. Our initial design for this project was to have an Arduino Duo hooked up to both an LCD screen and a music shield for outputting audio and video, as well as 5 capacitive touch sensors that would serve as the keys for the game. We would also use a buzzer to notify the player of an incorrect key hit. We started our project by trying to work out how the capacitive sensors would be used to trigger interrupts on the Duo. These capacitive touch sensors detected how long it took for the voltage change to propagate through an aluminium sheet. Because of the capacitance of the human finger, longer times meant that the sheet was being touched. Because of the way the Duo measured this, however, it could not be used to trigger an interrupt, so we decided to just use regular buttons instead. Our next concern was with how we would implement each song in code and how our scoring system would be realised. We went through several ideas but eventually decided to use arrays for both the song and the scoring. The song array was set up so that each beat of the song would be represented by a single element in the array. Each of these elements would then have a MIDI value that represented the note to be played on that beat. The scoring array was set up in a similar manner, with 5 arrays, 1 for each key. We decided that we would award maximum points for a perfect hit, some points for a close hit, and that we would deduct points for a missed note. Once we knew how our song would exist in our code, we went about coding for the screen. The libraries allowed us to draw different shapes and print text to the screen, which made our job fairly straightforward. Most of the library functions involved the size and position of the text or shape. So once we worked out which values worked for us, we went about printing an entire song to the screen, based off the score arrays. We started with Beethoven's Ode to Joy. Next, we started working with our music shield. After having some trouble using the peripheral, we were told that the shield we purchased was designed to work with the Arduino Uno's AVR architecture, as opposed to the Duo's ARM architecture. Fortunately, we had an Uno handy, so our final design had the music shield connected to the Uno, and then the Uno and the Duo connected through a UART connection. Unfortunately, the library functions included with the music shield were much more ambiguous than the screen functions and took some time to decipher what each function was supposed to do. Once we had worked out how to get the music shield to play the notes given a MIDI value, we looked to get the Duo and the Uno talking to each other. We referred back to our lab sessions to refresh ourselves on using the UART. We started with the loopback mode with the serial monitor to make sure our information was being sent from the Duo correctly. Once we confirmed we were sending the information, we wrote some code for the Uno to enable it to read the information sent from the Duo, again using the serial monitor. From here, we wrote code to send the song array through the UART to the Uno, where the Uno would play the note using the MIDI value it received. With both audio and video working for a song, we moved on to the user menu. The menu would allow the user to select between different songs and learn about the game via some help screens. We implemented the various menus using a finite state machine. To finish off the game, we added player feedback in the form of visual and audio cues for when a correct or incorrect note was played. When a key is pressed in time, a coloured bar will appear at the bottom of the screen to indicate a correct hit, whereas a red bar will appear for an incorrect note. We also added 2 more songs. Here's the final result.
Recording already?
Mm-hmm.
Okay, cool.